For example 3, again, we want to start first by factoring the top and the bottom. So if you want to go ahead and pause and try factoring on your own, and then you can check back in here on the video to check your work. All right, and if you have factored correctly, you should have found that in both the numerator and the denominator, we have the GCF of x. On the top, you had to do trinomials, which uses that grouping technique to get x plus 3. And on the bottom, once you took out the GCF, you just had that dots problem we saw in example 1. Now, step 2, super important. We're back to variable x. We want to identify where x is or creates an excluded value. So what values would create that 0 in the denominator? Well, the x itself will tell us that 0 won't work. And just like before, x plus 3 and x minus 3 will tell us -3 and +3. So for this one, we have 3 excluded values. Now, as far as cancellations are concerned, it looks like we have the same factor x plus 3 and x plus 3. We have another similar one, x plus 3 over x minus 3, but they're not identical, so we're going to leave them there. But we can get rid of the GCF of x's since it's literally x over x. That's like 1 over 1. So we don't need those either. So the final answer for this one would be x plus 3 over x minus 3. Much easier to look at than the original, right? And those two things are excluded values, and that simplified version create our final answer for number 3. All right, on to example 4. Again, some things to think about for this one. Factoring top and bottom separately. I will give you a hint. Factoring wise, you should be fine, but look for something weird to happen that did not happen in the ones previously, and then jump back to the video after you factored. All right, so factoring, you should have gotten z squared times z minus 2 and z minus 3 on the top, and on the bottom we've got z times 3 plus z and 3 minus z, a little bit weird way of writing the bottom there. Think about it. What do we want to do next? Our variable that we're looking at is z this time. So where is z going to be a problem for us? Where is that denominator going to equal 0? Again, we have z by itself, so that would be 0. And then 3 plus z and 3 minus z will each give us a positive and a -3 out of that. Now, as far as canceling factors, a couple things can occur here. So first of all, none of the factors completely match. What I do notice is that they both have a GCF of z, but one z squared. So what we're allowed to do is cancel out the squared and the z on the bottom because we have 2 z's on the top, 1 z on the bottom, so we can cross out one of each. The other thing that we're going to do here is notice how these two factors look super similar, right? We've got a z and a 3. The problem is that the negative is not right. So what I'm going to actually do here is I'm going to take a negative out, and really it doesn't matter if you do this from the bottom or the top. I'm going to take it out of the top just so since we already have that z out in front, but I'm going to take a negative out, and then that will change this to -z and +3. So now, even though it's not written in the same order, it's +3, like here, and it's -z, like here. So those two factors can now cancel because I put this negative out in front. Other than that, the other two, z minus 2 and z plus 3, aren't going to cancel. So we're left with -z times z minus 2 all over. I'm going to reorder this to z plus 3 because addition is what's called commutative. You can change the ordering without a problem, but you can leave it as 3 plus z if you'd prefer. And there are the two parts to our answer. All right, go ahead and pause the video and factor that last one real quick.